Have you looked at yourself in the mirror? Can you imagine what life would be without mirrors? This video will show that we can use mirrors to explain the properties of reflected light and the resulting images that we see.
What is a mirror? According to the Merriam-Webster dictionary, a mirror is a polished or smooth surface, as of glass, that forms image by reflection. Mirrors are reflective surfaces which bounces off light that produces either a real image or a virtual image. An object can be seen in a mirror if it is placed in front of it. It is the source of the incident rays, and the image will be formed by the reflective rays. An image can be identified as real or virtual based on the interaction of light. A real image is formed when light intersects, while virtual image occurs when there is a light at a certain point. Basically, anything with a smooth surface that reflects almost all of the light that hit it absorbs or scatters less.
The law of reflection was discovered by the Greeks, but it was explained by an Arab scientist 1,500 years later. The law of reflection is a principle that when a ray of light is reflected from a smooth surface, the angle of incidence is equal to the angle of reflection.
Plane and spherical mirrors. Now that we know how a mirror works, we're now going to learn about plane and spherical mirrors. Plane mirrors function because light rays create virtual image in the rearmost part of the mirror. Light rays that hit the mirror reflects on the law of reflection. An image will be of same size and distance in a plane mirror. On the other hand, spherical mirrors are mirrors that have curved surfaces. Spherical mirrors with painted inward surfaces are called convex mirrors, while those with painted outward surfaces are called as concave mirrors. Flat mirrors and examples. Mirrors with flat surfaces are called flat mirrors, which is the standard mirror without inward or outward curve. These days, mirrors are mostly made with glass sheets that has a thin layer of aluminum. Regardless of the materials used, every flat mirrors function similarly. Light rays reflect and it produces image. A concave mirror is a hollow sphere cut into parts where the outer surface is painted and the inner surface will serve as the outer surface. A concave mirror can also be called as converging mirror. Light converges when it strikes and reflects back to the reflecting surface of a concave mirror. If an object is placed near a mirror, it will produce a magnified and virtual image. An image will be reduced to its size and form as a real image when it is placed far from the mirror. Hence, concave mirror produces both real and virtual or smaller and bigger images. Concave mirrors can be seen on things such as headlights, astronomical telescope, head mirrors, and etc. Convex mirrors and examples. A convex mirror, however, is a cut hollow sphere with a painted inside, and the outer sphere will be the reflecting surface. It is also known as diverging mirror. From the word itself, it diverges the light when it hits the reflecting surface. It forms virtual, erect, and diminished images that will not change even with the change of distance. Here are some of the things that uses convex mirrors: sunglasses, vehicle mirrors, and magnifying glasses. Model. Here is an example of a device that uses mirrors. Reflecting telescopes uses mirror, specifically concave mirror instead of lenses. It is used to gather light and reflect it back to the focal point with the help of another mirror to direct the light in the eyepiece and lead it out of the telescope. Although various designs of reflecting telescopes were made, Isaac Newton's original design of it is still popular.
We all know the different parts of a reflecting telescope. Some of you might wonder, what is the difference between refracting telescope and reflecting telescope? Let us compare and contrast between the refractor and reflector and what sets them apart from each other. A refractor uses lenses without a tube to refract or bend light. It's the type of long telescope which you might imagine old astronomers like Galileo using. Reflectors, on the other hand, use mirrors instead of lenses to reflect light. Ever wondered how the reflecting telescope see that far? Well, here are its parts that made it possible. Number 1. The tube. This is the long white part and it holds the mirror, the secondary mirror, the eyepiece, and the holder. It is the whole optic system. Number 2. The mount. This is the whole assembly that supports and moves the telescope tube. Number 3. Eyepiece. It takes the light that's captured and focused by your telescope and magnifying the image that is seen by your eye. Number 4. Primary mirror. A concave mirror hidden inside the tube. At the end is the primary mirror that gathers all the light and reflects it back up toward the eyepiece. Number 5. The counterweight. This is a heavy weight that can be slid up and down on the silver bar to balance out the telescope and make it very easy to maneuver. Number 6. The motor. Not all reflector telescopes have this, but it is the motor that turns the telescope. It's the big black object. A classic reflector is a long tube, but instead of an objective lens like the refractor, it has an objective or primary mirror. An objective lens is at the end of the tube where the light comes in. Most modern observatories use reflectors because their telescopes are so huge. Refractors would not be practical. Their lenses would be very heavy and their tubes would need to be very long. And that's the different kinds of mirrors and their uses.
Now that you know a little more about mirrors,
We hope that we are able to help you. Thank you for watching.